it's always a big pleasure if you suddenly meet somebody in person where you know the content so well. So I have spent so many hours playing with Nicky's Explorables. I've recommended it so many times to people, so I'm personally really excited to have you here. Thank you for coming. And yeah, I'll hand over the microphone for our first keynote. Nicky, thank you.
Okay. Yeah, thank you so much for the free trip to Paris. It's really helpful. Anyway, I'll wait until people shuffle in. Hello, shuffle on in. Yeah, so some people just want to watch the world learn. There we go, that's my opening. Yeah, so you're here because you want to help others learn math. I'm here because apparently you think I'm good at helping others learn math. We'll see if you regret this soon enough. I just finished these slides 10 minutes ago, so you might regret this, inviting me. So for those of you who don't know, hi, I'm Nicky Case. I make games and interactive explanations to explain math and science. Oh, yeah, is this working? I guess it is. I'm just... All right. Okay. I'll just start over now that people are here. Can everyone hear me just fine? All right. I'll start my cheesy opening over again. Okay. Some people just want to watch the world learn. So you're here because you want to help others learn math. I'm here because you think I'm good at helping other people learn math. We'll see if you regret that decision very soon. So for those of you who don't know, I'm Nicky Case. I make games and interactive simulations to explain math/science. So at the risk of kind of tooting my own horn, here's a few things I made just to refresh your memory. Parable of Polygons. It's a playable simulation about the game theory of discrimination and segregation. This was one of my first interactive explanations. I made it in collaboration with Viharts, famous math YouTuber, and Mountain Hermit, who I haven't heard from in a year. Yeah, so, and then another one I made was The Evolution of Trust. It's an interactive guide to the game theory of cooperation. You know, what environments create trust or like create distrust. This one got 10 million plays for some reason, because I guess people really like cheating and game theory. Fireflies. This one's a sillier, smaller interactive simulation I made. It was based off Steven Strogatz's book, Sync. And this one is a little explanation showing how these fireflies in some Malaysian rainforest, they can all like coordinate to like flash on and off at the same time with no central leader. So yeah, that's like, you know, coordination of action without concentration of power. You know, that's something we could probably learn from. And then one I made a couple years ago, What Happens Next, Possible COVID-19 Futures. Yeah, in early 2020, like basically every math explainer kind of jumped on a bandwagon, and so did I. This one was a collaboration I did with an epidemiologist from EPFL, Swiss University, École Polytechnique de something. Yeah, so we collaborated on this and some other materials so that they could, you know, the team could help explain COVID-19 and like some strategies to a bunch of policymakers. And he explained to me, did you know that policymakers don't understand exponential growth or algebra or much? So yeah, it's like most of my past work, like it's hard enough like making stuff that's accessible even to a grade schooler, not make stuff that's accessible even to politicians. And finally, the last bit of self-promo stuff, but something that I just launched just a couple of weeks ago. So, and it's a tool that hopefully might be actually useful for a lot of you. So it's a tool to make expandable, embeddable explanations. So let's say you're writing a math/science explainer, and it kind of goes like, you write something that's like, a quantum gate is an operation on qubits, and your reader's like, what's a qubit? So they can click on qubit, and that little expands out to a little explanation inside the text that goes, a qubit is a superposition, a classic bit is either 0 or 1, while a quantum bit / qubit is a superposition of 0 and 1. And then your reader's like, what's a superposition? They can click on that, and that creates an explanation. And then there's something that they don't understand, they can click on that, that expands. So a nutshell lets your readers expand on details, just in time, always in context, so they can like dive into the details that they really want to. But wait, there's more. You don't have to write all the details, you don't have to write all the explanations yourself. You can embed explanations from other people or your own past work. You can even embed from Wikipedia, and you can embed from articles that are written even before Nutshell was launched. So hopefully this is practical and helpful for you. I just launched it a couple of weeks ago. It's free to open source. You can ask me during the conference on how to use it. Anyway, that's enough self-promotion. Let me actually make something that's actually helpful for you. So for this talk, I want to share my secrets on how I explain stuff. But first, I want to explain how I explain. But first, some theory about why I'm not going to give you some theory. Because explaining stuff is a skill. And when training skills, people usually think about theory versus practice. Theory is easy to share, but it's kind of hard to apply. While practice is hard to share, but it is intuitive to apply. I guess for example, I can't talk you to theory into being able how to ride a bike. So that's the kind of difference between theory and practice. But I think, and I hope there's kind of something in the middle where tricks, where it's easy to share and also hopefully also easy to apply. So that's what I kind of want to share today, kind of like tricks, heuristics, guides of thumbs. I guess the catch is that, most tricks are kind of false, I guess, for example, beer before liquor, you're in the clear, liquor before beer, whatever it is. Anyway, it's false. Most heuristics are false. So I recently only realized you can actually test your own heuristics. These tricks can actually be, also, in case you're wondering, I don't have the notes on the slide, so I'm reading off my e-reader, my own notes. So I'm sorry if I'm very fast. Did I mention I just finished these slides half an hour ago? So the idea that we should actually test and iterate upon our own tricks does not come naturally to human beings. So before I share these tricks, I want to emphasize that I actually, have deliberately iterated upon and tested these tricks for 8 years. I've been making these things, these crappy explanations. So without further blabber, testing out for hundreds of heuristics I've tried and narrowed down what actually works. So here we go. Nicky's top 5 tricks on how to explain things real good. Hydrate or dihydrate. So the first step to helping someone learn is to help them, actually want to learn. So trick number 1, show what made you care. Most textbooks are kind of fact dumps. And they seem not to really care about helping you care, but sometimes, it's even worse than when they do try to help you care, because it's kind of okay, for example, here's some other tricks that people have said on how to make your audience care, and they're technically true, but very easy to mess up. For example, make it interesting becomes, how do you do, fellow kids? Math is cool. Or make it relevant becomes, math is important because you can use it to calculate tips at restaurants or something like that. Or create a curiosity gap becomes kind of clickbait. Also, I should say that my top 5 tricks title is ironic. Do as I say, don't do as I do. The problem with these tricks make you kind of second guess your audience. So the solution, don't second guess what would make your audience care about some topic. Just share what actually made you care about that topic. An interesting puzzle, a clever solution, personal story. Show me what made you care. Also note that I said show what made you care, because if you try to share why you care, directly, it might end up being too abstract. For example, if you asked me hey, Nicky, why do you care about group theory? I would say something abstract group theory unifies several branches of mathematics and also its applications to quantum field theory, which is true, but completely abstract gobbledygook to a total novice. So it's better ask me, what made you care about group theory? And so only years after I learned about group theory did I finally care about it, thanks to this puzzle. Why do mirrors flip left and right, but not up and down? Why did, yes, actually that's the solution. Yes, they don't. But you're getting ahead of me. Which sounds like it's not even like a math question, but it is. And the solution, which you've already said they don't, is actually a pretty great introduction to group theory. And even better, once you actually understand the group theory of mirrors, you can use some algebra to create a true mirror. A mirror that does not flip left and right. Did you know that? That's right. Yeah, you can actually make a mirror that like only rotates around and like does not flip left and right. True mirrors that exist, and group theory can explain that. Yeah, okay, yeah. Yes, two flips equals a rotation. Yeah, there we go. That's group theory. I can't fool this crowd. But yeah, so the point is to avoid second guessing your audience, and being too abstract. Don't like tell me why someone would care. Like show me concretely what specifically made you care about some topic. And yeah, show me what's made you care. There we go. And to, why don't I just hold my notes up to my face like this? So speaking of showing and telling, once you've helped your audience, want to learn, how do you actually deliver? Well, trick number 2, show, then tell. So also all these slides will be posted online, so you don't need to frantically scribble notes. So show, don't tell is good for fiction, but not so much for nonfiction. So that's why I'm saying show and then tell. But one common and very natural mistake for educators is to make the opposite, where they just tell and don't show. So for example, like I love Wikipedia, and I give Jimmy my money every month, but here's the introduction to symmetry group. In group theory, a symmetry group is a geometric object with... Anyway, the point is what introduction, like how is this to help me if I don't know what it already is? So anyway, so the point is not show, don't tell, which is for nonfiction, or tell, don't show, which is what the case is for most textbooks, but show and tell. And I guess I'll specifically show and then tell, because it's still easy to mess up if you tell and show in the wrong order. So for example, this year I read this classic masterpiece of math exposition, and like I can to do better, and like me criticizing this book is like telling Michelangelo that, hey, you made the David's dong too small. Like, they're a master, I'm just a random person. So anyway, this book, it's great, I love it. Gödel's proof, it's about Kurt Gödel's proof. So anyway, there's this one point in the book, a little nitpick, where in this book explained what a formal mathematical system was, but he started by telling me, a whole page of technical definitions about what a theorem is, what an axiom is, et cetera, and I was totally lost. And only on the next page did they actually show me an analogy. Chess. Chess pieces are like math symbols. An arrangement of pieces is like an arrangement of symbols, also known as a theorem. The rules of how to move from one arrangement to another are like the rules of how to prove one theorem from another. Moving is like proving. It rhymes, therefore it's true. And then finally, the starting arrangement in chess are like the starting theorems in math, called axioms. And when they showed me this analogy, I was like, this is the most beautiful explanation I've ever heard of pure mathematical logic. Why didn't you start with that? Why was I did you let me get lost for an entire page? So anyway, the point is, don't just show and tell. Show, then tell. Concrete, then abstract. Familiar, then unfamiliar. And how can we do this concretely? Easy, just remember the acronym. P, with an A. Pictures, examples, analogy. So show me a picture like this, then tell me, what the technical definition is. Show me an example of a square being, show me an actual example, then tell me the technical definition of, what group theory is. Show me the chess analogy for pure mathematics, then tell me the technical definitions. Show, then tell. That's why I just spent 5 minutes explaining. Anyway, so sorry to just hammer it home. Just really need to just hammer this here. Anyway, so that's how you explain one idea. But I know, hear me out, this is crazy. What if you actually want to explain more than one idea in your explainer? What you gonna do? So try not to do a listicle. Again, my top 5 tricks thing is ironic here. Instead of a disconnected listicle, give me a connected story. See, that's connected story. Visualization there. How? With this trick number 3, therefore and but, not and then. I'll let that just sit with you while I, this very self-explaining thing sit with you while I take some water. Also, am I speaking too fast? No? Okay. Cool. Am I speaking too slow? Okay. Imagine you have, okay, let's keep going. Therefore, but, not and then. Imagine you have a story that goes, once upon a time, some guy gets superpowers, and then some other guy dies tragically, and then there's a grand, beautiful moral lesson. Have you noticed how a lot of Hollywood movies kind of feel like this? Kind of like a series of grand set pieces that should be emotionally moving on paper, but ends up kind of hollow and flat. I kind of reckon that's because a lot of these scripts are written, are connected with an and then, not a therefore and but. If events aren't consequences of each other, they won't feel consequential. It almost rhymes, therefore it's almost true. So contrast this to this story. Peter Parker was a kid who got no recognition or respect, but one day a spider bites him and gets him superpowers. Therefore, he uses his powers to get recognition and respect, but his irresponsibility indirectly causes the death of his uncle. Therefore, he learns the grand moral lesson: with great power comes great responsibility. That's the kind of modern fable that gets kind of embedded into our cultural memory, like, like cry wolf of sour grapes. Because why? Because this shows the therefore buts loop of every great story of life itself. There's a conflict, therefore a character changes something, their actions, their beliefs, their deepest values. But this creates a new conflict, therefore they change again, but a new conflict, therefore they change again, repeats over and over in books and in life. That's how you get real character growth, I assert. So this therefore and but trick was coined by the creators of South Park for writing fiction. But a few years ago, it was also repopularized by Tony Zhao, the creator of the video series Every Frame a Painting for nonfiction. So here's an example of using the therefore and buts loop for nonfiction, explaining how a piano key works. Here's a GIF of the inside of a piano key. Is this self-explaining to you? Can you understand what's going on here? Does this help? So no offense to whoever made these two things. They're like, they put a lot of effort into it. Like they obviously understand the technicalities of it. But again, for a beginner, it's very like this and then that. Here's the back check, and then here's the hammer shank, and then like I can't understand this. Tell me the therefore buts loop. So contrast this to a video from this year by the engineer Mark Rober, who used the therefore and buts loop to explain why a piano key was designed in this particular way. So first you start with the problem. You want to play a key, you want to play a note when you press a key. Therefore, you try the obvious solution where you make a hammer hit a string when you press the key, right? But there's a problem. If you hold the key, the hammer stays touching the string. Key stopping it from vibrating meaning it can't play. Therefore, you add a kind of a flicking mechanism so that the hammer is flicked towards the string, but then comes down right afterwards. But now you have a new problem, is that when you release the key, it won't stop playing. Therefore, you add a dampener so that when you release the key, it stops the string. But this causes new problems, and then there's a bunch of other stuff that I can't remember. But anyway, the point is like, why the piano key is this complicated is because of this therefore buts loop. Like someone had a problem, so they had a solution, but it created more problems, more solutions. So that is the story behind like every great invention, whether that's in engineering or math or science. Yeah, you have a problem, therefore solution, but problem, therefore solution. In science and in life, that's how we get real intellectual growth, I assert. So the next time you try to explain a complex idea, don't give me a disconnected listicle, this and then that. Give me a connected story, therefore and but. And as we saw with the humble piano key, you don't have to make up the story. The story is already there. So our first 3 tricks so far out of my top 5 tricks, show what made you care, show then tell, therefore and but. These will help make your explanation more beneficial for your audience. But it's not enough to think about benefits. You also have to think about the costs, specifically the cost of time. Our time being alive is precious, as I guess we've all learned the hard way recently, and it's an ultimate non-renewable resource. Therefore, yeah, there we go. Therefore, we need to respect our audience's time and be concise. So trick number 4, write a draft and cut 10%. No matter how good you get at writing, at least 10% of your first draft will always be fluff. Redundant words, non sequiturs, redundant words, fluff. So find the fluff and cut it. That is, write a first draft and get a word count. Multiply the number by 0.9 to get 90% of your word count. Then cut the draft down to meet this new word count. There's so much more I want to tell you about being concise, and I won't. So trick number 5, do real tests early and often. So here's a fun story. In the 4th century BC, well, I guess I can wash that later. In the 4th century BC, Aristotle claimed that heavier objects fall faster. Everyone thought so. This was just common sense. And then in the 16th century AD, scientists actually finally tested this. It's false. You can test it yourself, just by taking 2 objects, 2 lead balls of different sizes and weights dropped from the top of a building will fall with equal acceleration. As an aside, Galileo himself didn't actually test this empirically. He proposed the thought experiments, but other scientists at around the same time actually did do something similar. Anyway, the point is, 4th century BC, 16th century AD, that's 2,000 years that we just believe this thing that you could have tested yourself by just taking 2 random objects. And I'm not going to drop the microphone. That'd be funny, but there's other people doing keynotes. But the point is, that's how long it took humanity to discover this thing you could have tested yourself in your own room. Like I mentioned at the very start, the idea that we should test and iterate upon our ideas does not come naturally to us human beings. Heck, given even this replication crisis, it probably doesn't even come naturally to most scientists. But it's especially hard to test our own ideas in the creative arts or math exposition, such as making an explainer article or video, because it's hard to put your own creative darlings to a trial by fire. And I'll admit, trick number 5 is still the hardest for me. Oh wait, what's my next slide? Oh, exclamation marks on my next slide. There we go. Yeah, the idea that we should test our ideas does not come naturally. And this trick, the idea that we should actually test our ideas, is still the hardest for me. But I'm trying to get better. So for a concrete example of what I mean by do real tests early and often, here's the story of how I tested and iterated upon this talk. Yeah, wow, so meta, 4th wall, so nice. While I was writing this presentation, I was having dinner with 2 friends, and I wanted to actually test this talk with them. And so I told them, so I guess usually I test my explainers only after I've written the first draft, but this time I only had I only had the outline and some index cards and a pencil to sketch out some stuff. And then I told them, please heckle me, because usually only when I test my explainers, I only ask afterwards what was, boring, surprising, confusing. But no, I want to actually do a real test. Have them interrupt me in the middle of my presentations. Hey, am I skipping over some things I didn't explain well? Am I talking too fast, too slow, etc.? And then afterwards, I asked them, hey, could you actually summarize what I just said? Not as a test of your memory, but as a test of did I actually explain well, etc. So anyway. So that's doing a real test early and often. So the next time you try to test an explainer, don't just share, don't just share for feedback after you do the first entire draft. Like, get it early and often, like even when it's just an outline, and use sketching on some index cards. And encourage your friends to actually heckle you. Because in science, politics, life, and art, we should do real tests early and often. Because when humanity forgets the idea that we should test our ideas, we deceive ourselves, apparently, for 2,000 years. So, in conclusion, these are the 5 tricks that I keep coming back to that have stood the test of time for me. And I put my slides in the wrong order because I was rushing it, so let me just skip over some of this and get to the 5 things. 1, show what made you care. Don't just tell me why you care. Show me the actual concrete stuff that made you care. 2, show, then tell. And then you can use the 3 tricks. P, pictures, examples, analogy. Also, if you want to take a picture of the 1 slide summary, here it is. I'm posting it online, so you don't have to, but that's all right. Get your little anxiety rectangles out. Take a picture. 3, therefore, and, but, not and, then. Also, kind of do that problem, therefore solution, but another problem, therefore solution loop. 4, write a draft, then cut 10%. And then 5, do real tests early and often. So, dear listener, here's our story loop that I'm going to skip back slides on. Problem. There's a beautiful, important, complex idea that you want others to know about. Therefore, your solution, you write an outline of an explainer. What made you care? Concrete examples. The therefore and but loop. And you improvise a talk early and often for your friends. But your friends like it, but there's some boring parts, there's some parts that are a bit confusing, they misinterpret other parts. Therefore, you take in their feedback, you write the first draft, and you cut it by 10%. Then you send it out for more feedback, but there's more critical feedback. Therefore, you iterate upon it again, over and over. And you repeat until your explainer has gone from good to great. You hit publish, and you show it to the world. The end, for now. This is the story loop of some people like you and me. Some people who just want to watch the world learn. Thank you. Thanks. Yeah, thank you for listening to me. And sorry, my eye contact was not making any eye contact because I didn't put the notes on the keynotes. They're on my e-reader. But yeah, so I have a lot of extra time left. How much time do I have? Like half an hour? Yeah, so anyway, just a couple things. Sort of the Q&A, or you can ask me. So like just things like I'm curious about, and like I would love to chat with y'all during the conference or during the Q&A about. So 1, nutshell, my little tool for making expandable explanations. 2, virtue, character, education, and math. I recently read this book by Francis Su, the former president of the Mathematical Association of America, and also incidentally the first person of color to be the president of the MAA. Finally an Asian who's good at math. Yeah, he wrote a book called. Thank you. He wrote a book called Mathematics for Human Flourishing, and it's about like how the kind of virtue, the kind of character traits that you get trained with by learning math, like apply to like all of life. Like for example, like good math problems like train you to be both humble yet also determined, which is a thing that's lacking in a lot of people's lives, especially in politics. So yeah, let's chat about like how we can use math education to help people excel in all of life, not just school and their career. And also, like, I'm curious about, like, if you want to chat about, like, say, computerized tutors, because most replicated studies show that one-on-one tutoring is, like, extremely helpful, but, it's not scalable or equitable or whatever the buzzword is. And, yeah, if we could have, like, computer tutors that are, like, even as half as good as a human, but, like, 1% the cost or, like, free, like, hopefully that'll help, a lot of people and, like, bridge, narrow the poor-rich gap in academic or mathematical achievement. I'm also really interested in statistics, and I'm going to spend the next year like getting really into it, especially causal inference, biostatistics, and control systems. I guess, especially after the whole pandemic, like I guess a lot of people, especially including me, are very interested in biology, and I want to learn. I want to learn about it. And I guess that ties into my final thing I want to like chat about in the Q&A or during the conference. Just find me. independent research. Like the last several years, I've been like explaining other people's research, but like I want to like kind of try to do my own, which is easier said than done. So if you have any like advice for someone who's, I'm also not affiliated with any official institution, so if you have any advice on like how to do indie science cheap and quick, let me know, because I don't know. So yeah, those are things I'm curious about. Please find me during the conference and chat about it. Anyway, yeah, so thanks for listening to me ramble for my slides I just finished 1 hour ago.
Thank you, thank you. So the Q&A is open. So we have questions from your side. There are questions here towards the audience too. I'm going to bring you the microphone. Who wants to start?
And now I'm going to take notes on you.
Yeah. Ben. Yeah.
All right. So thank you for this nice talk. And I'm sure that you've collaborated with lots of experts in their own fields who want to communicate their science and their work. So I was wondering, going from the what to the so what, or from the answers to the questions. I think Stephen Strogatz explained it like this. Experts have all the answers, so many answers that they keep forgetting the questions.
Right.
So I was wondering, how do you collaborate with these experts? Do you find the questions for them? Or are you able to sort of help them find the right words and the right exposition? Or do you do the exposition for them? Is one easier than the other, or would you like to do the harder part easier? I mean, the one thing is doing this expository work for the scientists, and the other is showing them how to do it themselves.
Yeah, I mean, that's actually partially why I made this talk, is so that people can, so that domain experts can basically not steal, but like take my tricks and like apply themselves. Because the way I put it is like, if you don't explain your stuff to a public audience, some underpaid, overworked intern at BuzzFeed will do it for you, and they will not do it well. So please.
Or the other side.
The what?
Or the other side.
Or the other side, yes. As we found out during the pandemic, or I guess climate change, or actually a lot of things. So yeah, I guess I made this talk so that they learn, so that every domain expert gets to know how to do it themselves. And I guess, yeah, my advice for that is show concretely what made you care. Because I guess, that's a good way you put it, that they're so focused on the answers that they've forgotten what questions got them into the field in the first place. So I guess like for me, like I asked them like, what got you in the field in the first place? Any interesting like questions? And I guess like, and also I guess like if I reached out to the expert, like then I remember like what got me interested in the topic in the first place, so I can just share that as the kind of the frame for it. And for some experts I've collaborated with, like the most recent one was the one about the COVID-19 pandemic. Like it's pretty obvious why people would care about that. So I guess I didn't have to do much work for framing it that way. So I guess to answer your question is, I just show what's made me care, or ask them what specifically got them into the field in the first place.
Yeah,
Good question. Thank you.
Okay, another question? Yeah, Olga.
Thank you very much for your talk. Thank you for mentioning, I'm here. Thank you for mentioning this YouTube channel called Every Frame a Painting. For those who don't know it, I really love it. It's about cinema and storytelling. It's very beautiful. And my question is, maybe they're related. I have two questions. So what is your audience? Do you know people who watch your videos? Do you have a community of people who give you some feedback? I imagine since it's mostly on the internet, you have more feedback than some other people. And the second question is how you make a job of your hobby. So it's more budgeting kind of side.
Right.
So my knowledge is mostly based in Russian and French situations, and most of my friends who do outreach in Russia are having another job in the academic institution, for example. And in France, there are some different forms, but either related to museums or on Patreon and feeding from community. So what is your strategy in US? Thank you.
Yeah, that's a really good question. And yeah, it's the internet is hell, but also kind of my job. So yeah, so I guess yeah, I sort of listen to internet comments, but internet comments, as you probably all know, are kind of hit or miss. So I guess like yeah, I have like trusted friends that I trust who can like give me honest feedback. And I guess like as for like actually getting to be a sustainable level, like yeah, I guess I was doing this for like 4 years until it was actually sustainable for me. So I guess as a general like advice for like anyone who wants to like become independent is like do the hobby while you have an actual day job. So like I was having a day job for like the first 4 or 5 years until finally the game theory thing became randomly popular, and I still don't know why. And that actually boosted my Patreon to be able to pay my food and rent, which is like, damn. Yeah, so, and I guess there's no harm in like just like having a Patreon that's up and just like linking out all your stuff, and like you just let it accumulate people until it hits like whatever goal you have set for like when that actually covers your food and rent, and then you can be like, all right, now I'm gonna quit or keep the day job, might as well. Yeah, and actually that's what the strategy did. Actually, yeah, Vihart right now, she has a day job at I think Microsoft, and she still has the Patreon. So a lot of people are supported that way. And like Tony Zhao from Every Frame of Painting, he's always had a day job as an editor while he did the series. So yeah, this is the kind of like the more messy, not sexy side of like being an internet creator is like, sometimes you just have a day job or a very understanding partner. I'm not sure if that answers the question. Fair enough. Merci.
Thank you. Ricardo? Maybe I just...
So, hi. I have a question about social media. Like,
I have a lot of questions about social media.
yeah, me too. And because when you said like you keep 90% of the word count, and on now the social media you have like you keep 10% because you have to be very fast.
Yeah.
Do you have any particular suggestion on? Do you think something changed with respect to the suggestion you did, or?
No, I still do 90%. Well, I mean, I guess for Twitter, like I have to use an actual character counter to make sure it's less than 280. But yeah, I don't know. I just found I guess like of all the kind of like the right concisely advice, like I guess like Strunk and White's classic book, The Elements of Style, is the first half is still pretty useful. Please ignore the rest of it's kind of like, what's the word? Very strict grammar school kind of its vibe, but yeah, I feel like you just like take 90% of your word count and like cut it down. Like seems to like basically capture all the other advice. Like all the other advice, like kind of stuff like skip out adjectives or like blah blah blah. Anyway, the point is, yeah, just make it concise. Just do it. Just do it. But yeah, as for like other social media advice, I don't know how social media works. I guess have a good GIF, have a nice thumbnail that like, actually I guess that's another thing I've been working on recently is like, oh, I guess it's at the very first slide. Never mind, I'm not gonna go back. Yeah, have a thumbnail or a GIF that will basically like, can people like understand it just from the thumbnail and the title alone? It's like, yeah, assume people have an attention span of like 5 seconds, and that's kind of honestly pushing it. So there you go. That's not really advice. That's just a constraint that you have to be aware of.
Yeah. Thank you.
Yeah. And I guess the other constraint is that if you're writing about something like this more politically charged, like try to write it in a way that minimizes the chance that you'll be misinterpreted, which you will be by any sufficiently malicious actor, but try to minimize it.
Emil?
Okay, thank you for the talk. To some extent, my feeling is the mathematics is the most accessible secret science that we have, because everything is accessible now, even in a better way, as we see, but it remains secret to many people. And I had a friend of mine when we were studying mathematics, and there was one teacher there who told us in a great way something about, and then the question of this friend of mine was, did he teach us now mathematics or did he teach us presenting? And that's an important point probably, that if you look at somebody swimming and he tells you all the things in the way keeping on your tricks, yeah,
Right.
then you will know a bunch about swimming, but you will not become better in swimming.
Right.
And how can you somehow bridge this gap between training and the real doing of mathematics and the watching somebody explaining, not even doing, because you are not showing your mistakes, which is an essential part in doing mathematics, or maybe you do, I don't know. And that's a question. Yeah.
Yeah, it's actually a really good question. I've been like doing a lot of like research about it. So I guess two things that come to mind in terms of like, how do you make like, how do you train people to actually do mathematics, but in a way that's, scalable, equitable, like, so you don't need to have one-on-one tutors for everyone. So two things that come to mind is I read last year George Polya's, I can't believe it took me so long to finally read the book, How to Solve It by George Polya. And like, it's really amazing like how the book is just a list of questions and it's actually really concretely helpful. It's like, I guess like, so some of like the prompts like he has is like, when trying to solve a problem and you're stuck on it, think of a simpler related problem. And like, that sounds obvious in hindsight, but like to most people, and including to me, like it's not obvious in advance. Another one is like, don't just learn from your mistakes, learn from your successes. And I'm like, learn from your mistakes has been obvious to me, but I've never actually thought to learn from my successes. Is this why I have an anxiety disorder? So yeah, stuff like that where like, it's just like a simple like, when this, then think about doing this, or then do that. Like when X, do then Y is like extremely shareable. Like it's like if this, then that. But like that actually like trains you like an actual skill. Like George Polya's book is successful among students, and like, yeah, it's just like, when this, just think about that. And like, I guess that's me roundabout saying like, that might be like, I guess a trick, a heuristic, like something that's like both like extremely shareable, but it actually does help share the actual procedural knowledge, the kind of like actual skill of doing mathematics. Another thing that comes to mind is the research on worked examples. So I guess this is big controversy in learning education about like how much do you do like direct instruction versus like hands off for the teacher but hands on for the students, kind of like unguided instruction. And worked example seems to be kind of the bridge between that, where like in the beginning you just basically show. I guess it's how YouTubers like explain how to do like motor skills like origami or juggling, is that you just show how to do it step by step. And same for, I guess, the research, and I guess I double checked that it's been replicated and it's robust, that it's just like showing worked examples. Oh, yes?
Just shortly, it's great with the worked examples. I have a completely different experience when I give my students not just examples which are not worked out, but worked out examples which they have to present. So they don't have to do anything beyond studying this worked out.
Doesn't work?
It doesn't work. It is extremely strange. It doesn't work. It's not that you would expect they will mark more of those. It's not the case. The opposite is the case. They are somehow afraid. I have no idea. So I'm very curious about research on teaching you by using worked examples. It's extremely interesting.
Yeah, that's actually a good. I actually haven't heard of. I mean, like, obviously, must counterexample exist, and I guess it's my first one hearing of it. And I guess that's the problem with like a lot of research in psychology is like it's a heterogeneous effects, which is the fancy way of saying it works for some people and it works for that, and it doesn't work for others. Which is like, well, I guess we'll find out why at some point. But yeah, I guess another like thing that's interesting about the worked examples research, and I guess this is more like in the early stages of research is, I like it though. It's called backwards fading, where you start with a fully worked out example, step 1, step 2, step 3. And then the next time you present it, it's like, step 1 is done for you, step 2 is done for you, but in step 3, you have to do it yourself. And so this way, and then the next time they do it, it's like, step 1 is worked out for you, then step 2 and step 3, you have to do it yourself. And then finally, you do all steps yourself. And this is how you bridge the gap between just following a lecture and then to actually doing all of it yourself, kind of like the backwards fading. The kind of the cheeky quote I've heard is like, if you want to teach a kid how to bake a cake, first you start by letting them help with the icing, the last step. So they get that sense of accomplishment, being like, I finished the thing. It's an easy step, but I actually brought it across the finish line, which is so much more motivating than doing a step and then the parent finishes it for you. It's like, no, I did the finish line. Yeah, and then you just work backwards from there. Yeah, again, this one needs more replication, et cetera, to be more robust, but I like it. Sounds cool, plausible. Yeah.
Okay, I think we are done with the time and keep questions. Olga, okay, we'll do the final one.
I have already asked the question, but I really feel the urge to make a comment about this question. Why we as researchers, because you are in research, right? Why we as researchers feel that mathematics is a secret science. And I will tell more about this in my talk, but I recently started understanding that it's not all about math. So this is, we have many math teachers here, and I think they have probably more knowledge than us researchers. About the reasons why people, it depends on context and on countries and on situations, but why a person, let's say a girl from some small city, thinks that math is secret and accessible, and even maybe more probably doesn't know that there is some math to learn. They think that everything is done by some people somewhere. And I think it's not, and Nicky was answering on the didactics of how you explain math to somebody who is already in the bakery, who already has eaten the cake, or at least seen the cake and liked the cake and dreamt about the cake. If I were a baker and I would say to somebody, I'm a baker, usually people react, oh, I love chocolate cake or something like this, right? When I say I'm a mathematician, it's not the reaction I would have, right? The question is, who is this responsibility that the math is secret for people? I think there is also the question of, we know math, let's suppose that. We know how to teach math, let's suppose that as well. But do we know the world, do we know how people, other people, not us with our relationship with math, maybe we had teachers or parents or people who surrounded us in life, who supported us during our studies, who shared the love of math and also the style, the culture of math. Some people don't have anything of this. Somebody has never eaten cake in their life. And when we say to them, oh, it's so interesting, the second layer of cake, I think we have to remember the real world, because the question of outreach is about real world. And I think the work of Nicky on trust, evolution of trust, and how to speak, one person speaks to another, the question itself is not about math. Maybe my theory, maybe that's why people were interested and watched the video and learned about game theory. And I think this conference is very important, and we as researchers have to be very careful of what we say about math, because we are not the only ones to think about this. There are math teachers, there are children, there are people outside in the world who need it. And if we keep thinking that we have the secret knowledge which belongs only to us, we are going in the wrong direction. If we want to teach a child who is already interested in math and excited, we will probably be successful. But if we want to touch somebody else, if we are thinking why mathematics is so secret, we should think about ourselves first.
Yeah, and that's actually why that's actually why I emphasize the show what made you care, because actually that's a great analogy. Like can they? What's the first way they can get them into the bakery and actually taste the cake first? So I guess that's why I emphasized in the beginning, show what made you care. So for evolution of trust, like at the time people were wondering about trust in the internet and on the world in general. For COVID-19, a lot of people were thinking about that. So and I guess, yeah, for the group theory example is, yeah, like, why do mirrors flip left and right and not up and down? So yeah, like getting them to like, I guess, whet their appetite. Here's a taste of the cake. And it's like, wow, this tastes delicious. Now here's how it's made. So I guess that's another way of explaining my step one here is, yeah, show what made you care is identical to like, give him a cupcake before explaining how cupcakes are made. There we go. Yeah.
Thank you, Nicky.
Thanks for inviting me. Thanks for listening to me ramble. I hope that some of this was helpful. Come chat to me about stuff like nutshell and other biostatistics and stuff.
We will. Okay, then, yeah, we are going to have the next session right away on innovations in mathematics museums. Adrian, you're going to chair the session, and I call the first speaker on stage.